In today's video, we're checking out AceVolt's all-new power station. After getting this out of the box, the first thing you'll see is a manual, an AC power cord, and also a DC power cord for solar panel hookup. As we take a look at the specs of this power station, it comes out to $1,700 at the time of this video and has almost 2,000 watt-hours of capacity at a 2,000 watt AC output, 4,000 watt surge, 1,100 watt supercharging rate so it can fully charge in 2 hours, and has a solar input of 500 watts max at 50 volts or 20 amps, and is UPS rated so it can be uninterrupted power supply for all types of devices. On the very back of the unit, it comes with a specifications plate. That way you'll always know how much power each one of the plugs puts out. As you take a look at the weight of this particular power station, it comes in at just about 50 pounds, which is the size of a small generator. To turn on the AceVolt power station, you just press and hold the power button for 3 seconds, and this will power the unit up. As we take a look at the left side, this will have a few DC charging ports like a 12-volt socket, which will provide up to 10 amps, and then also an XT60 port, which this isn't as commonly used but could be used for RC cars and a few other items, and will provide 10 amps as well. Just below that, you will see 2 round DC ports, and this is a DC 5521. It's just a little round plug. Now, this is something that charges up a light that I have, which has a 12-volt socket, but the little DC round port looks like this guy, and you can charge up little USB routers or power those items up. And then if you want to turn this on, you simply hit the power button, and you'll see the icons come up on the display, meaning that this is powered up and ready to go. As we take a look at the middle, this is where all of our USB plugs are. This will have our USB-A type connectors, which will have your standard charge, quick charge, and then your USB-C type, which this will be 100 watts out of both of these units. And you just simply press that button on, you'll see the USB icon come up on the display as well. As we look at the display, you can see here on the side, this will show us our discharge remaining as far as hours or minutes, along with our percentages charged, and then also input and output wattages, along with our hertz, which we can actually change that to 50. AceVolt also added a light so you can definitely see in the evening, which this is very bright, which has a steady on position. It also has a SOS pattern, and then it also has a strobing pattern, which is very bright and definitely will attract attention if need be. On the left side of the machine, you'll see a couple of vents here that has your cooling fans and also a circuit breaker that's up top in the middle. And below that, you'll see this is where our charging ports are. We have an AC charging port and a DC charging port, which we'll go over this section here, which is our solar input in just a little bit. And we'll also go over the AC input as well in just a minute or two. As you open this door, you'll see both your inputs there. Now, one thing that's nice about AceVolt is they just give you a charging cord and you don't have an external charging brick or some external charging pack, which is nice. For your DC charging, they give you a set of cables that has an Anderson connector on one side, and then on the other side of that, they give you MC4 connectors, which these are really popular for hooking up solar. Now, one thing I did notice is that the side panel door here is actually very similar to the EcoFlow Delta Pro panel that I'm holding in my hand. If I was to actually remove the door on the AceVolt, I'm pretty sure I could swap these side panel doors and they would fit just fine. So it makes me wonder, are they using other products inside that EcoFlow happens to be using as well? So might make for a good power station. As we take a look at this side, these 20 amp plugs are also very similar as well, which I do like the spacing of these because they give you 6 and you have enough room to actually utilize some of the bigger plugs. So if you have a plug that looks like this, you have enough room to actually add more of the same size, or if you want to just add the standard plug, there's plenty of room for that. So we're going to go ahead and do a little bit of solar charging now with this power station, and I have 3 solar panels right here. These are from Harbor Freight, and each one is 100 watts, so 300 watts total. Now, it says we can do 500 watts, but that's not always the case. So I want to show you something here when I hook all 3 of these up in series. Now, one thing I would like to see is that AceVolt actually provide a longer cable. This set of cables is actually pretty short. It's only about 18 inches long, which if you want to have any kind of a solar hookup and your power station somewhere else, you're going to need something about 3 feet. At least it is a good cable though, because it does feel like it's quality built and it is 12 gauge, but I would rather have a longer cable. So I have 3 solar panels hooked up into this little power analyzer, and it's going to give us some information like our voltage. Right now it's open circuit, it's not plugged into the power station, but this only has a 500 watt rating or 50 volts max. So you can see by looking at the voltage, it's actually a little bit too high, because if we go back and look at the manual and you take a look at here in your input, it says 11.5 to 50 volts or 20 amps. So I could actually parallel the panels and get a lot more amperage, but I'm going to just disconnect one panel and we'll go with 2. And now as we take a look at our voltage, we're at 40 volts on an open circuit, nothing connected yet. And so this is a lot safer, and we'll take a look at our amperage when we connect it. Okay, so everything is now connected, and we'll take a look at the meter here and take a look at our numbers. So it shows about 35, 36 volts coming in, 115, maybe 120 watts, and then also about 3.5 amps. As we take a look at the power station, it's pretty much reading the same at about 115 watts coming in, but I need to move the panels. So now that the panels are moved, they're actually laying flat and the sun is directly overhead. This should actually boost the power up quite a bit. And now as we take a look at the power station, you can see it's bringing in just over 170 watts now that we got those solar panels at a better angle to the sun. And as we look at the power meter, we're bringing in about 180 watts right here at the meter, which we lose a little bit by the time it goes into the power station, but it would be nice to get the amperage up because then that would get us closer to that 500 watts. So it wouldn't be a bad idea to take two solar panels and put those in parallel and have your two in series to up the voltage and the amperage to get us closer to that 500. So we're going to take the unit inside now and we're going to charge it up with an AC power cord to check out the supercharging feature of this particular unit. But this is actually where I ran into a problem. So what happened is that I plugged this into the power strip that's alongside of my table here, and after about 3 or 4 seconds, it ended up blowing the breaker on the main circuit in my garage, and I couldn't really figure out why. So it took a couple tries to figure this out, but looking in the manual, it actually says do not use an extension cord and do not use a power strip of any sort. You'll want to plug it in directly into a wall socket. So that's basically what I did. I plugged it into the GFCI outlet and I made sure that everything else in my garage was completely unplugged. That way nothing else was drawing power on this particular circuit. But again, after about 3 or 4 seconds, it ended up popping the breaker again. Which this was actually starting to get confusing because you should be able to charge this off of a 15 amp circuit, which now I'm kind of wondering if there might be a problem with this particular unit because it is an early release. So I took it inside the house and I tried to charge it in the bathroom. I tried to charge it in the kitchen and it wouldn't work. So I'm wondering if this particular one that they sent me might need an update. Now, I did try to do something with my EcoFlow Delta. This is an older model because this will also charge up at 1100 watts, but it ramps up really slow. So I wanted to make sure nothing was wrong with my garage or a problem with a circuit breaker. So I decided to plug this in real quick just to see what would happen. And as you can see, it ramps up pretty slow and it starts charging and gets almost to 1100 watts. So it seems the garage is fine. So because I wanted to continue testing and check out the supercharger, which seems to be working fine, it's drawing 1100 watts, I ended up just plugging it into the EcoFlow that I have. That way I could get this fully topped off so I could do a load test and also do a capacity test on this unit. So we'll just come back in a little bit when this is fully charged so we can check a couple items. Okay, so the Ace Volt power station is fully charged up and we're going to check out the UPS feature of this particular unit. This means it's an uninterrupted power supply and it'll automatically kick on power within 10 milliseconds to power up devices such as maybe a Wi-Fi router or security cameras, a refrigerator, and more. So right now it's doing pass-through charging. It's actually just basically passing AC voltage through it through a set of lights that I have running, and we'll use that hairdryer too, and then we'll pull the AC charging cord out and that'll act as our power interruption. So right now we're just going to take this hairdryer and we're going to turn it on to the fan only, and we're not going to use the heating element. And this should draw about 100 watts give or take, and then also the lights that are running on that orange extension cord there. So you can see 71 watts right now. We're going to go ahead and disconnect the AC power cord. And now you can see the unit basically stayed on and switched power to the battery, and there is basically no interruptions. So right now we're drawing about 155 watts, which I'm kind of wondering why it didn't show that earlier, but one thing I do want to show you is that when this unit is plugged into AC, it powers on. And so when you want this to do the UPS mode, it'll stay like this. You can't actually shut it off. So if you would hold the button for 3 seconds, it should shut the unit off. But if you want it to be in UPS mode, you have to leave it plugged into the AC source and turned on, which there's actually no way to turn it off anyway. Even if I hold the button for 5 seconds, it still stays on. So that is one thing I found a little odd because it is going to draw power if you just have it sitting here on standby. One small feature this Ace Volt power station has is you can change the voltage on it depending on where you live. So if you have 100 and 220 volt, you can change it to 110 and 230 volts. So if you happen to be in the States, make sure that you put this on to 110 and 230, that way you get max voltage. We'll go ahead and do the inverter test now to see how well it handles a load. So we're going to use this hairdryer and also this heat gun and see how well it does at holding a 2000 watt load. So right now you can see that it's pulling about 1200 watts, and then we're going to use this hair dryer as well, and we'll just kind of ramp it up slow until we get to about 2000 watts and hold it there for a minute or so, and then we'll do max just to see how far this will go up and how long it'll hold a max load past maybe 2000 watts. So now we have both items running, and we're going to get this up to 2000 watts roughly, and we'll just kind of hold it there, and then we'll go above that to see how well it actually goes above if you happen to have a small surge, because some power stations actually will shut off only about 100 watts over their actually designated running watts. So we'll see how well it does here in a second. We'll go ahead and just turn it all the way up and see what it does. So now the hair dryer is all the way up, closing in at almost 2600 watts, and so far doing just fine. So if you happen to be using some kind of a small heater or maybe a cook plate that happens to kind of jump in wattage, this shouldn't have any type of a problem running it for quite a while. And so far it's still running and it's not kicked off yet, which so far this is actually pretty good. Now you don't want to sustain this because you could burn up the inverter, which could cause some problems later, but I assume this should start kicking off here any second. We'll let it run for, well, and actually there it goes. So it overloaded and shut off, so we'll go ahead and reset. So now we're going to be doing a capacity test, and we're going to see how many watt hours we can actually get out of this unit. We'll use a kilowatt meter to keep track of our runtime and also how many watt hours we get. We're going to use this as our load. This is going to be our little AC unit. This is a 5000 BTU unit, and it draws about 450 watts using about 4.1 amps. So we'll have this running along with also a small set of lights that's on that orange extension cord. And so right now you can see it's drawing about 42 watts, and we'll go ahead and turn on the AC unit now, get this fired up. We're going to go ahead and turn this all the way up to max fan and max cool, and we'll take a look at the watt meter over here real quick. So you can see it's 116 volts currently and using about a 470 watts. And actually one thing I do have to do is take this extension cord and plug it in here, because those are the lights I was using, and that's about another 40 to 50 watts. So now as we look at our watt meter again, now we're at about 500, and this will go up actually as everything gets a little hotter. And as we look at our amperage, we're at about 4.3, and then we can keep track of how many watts obviously, and with that little pink button over there, that'll be our timer and also our kilowatt meter as well. So this is what's going to keep track of everything, and we'll see how many watt hours that we actually get out of this unit, and then we'll compare it to what it's actually specified for, and we'll see what it looks like at the end. So we'll pull this out, and now basically the test is beginning, and we'll see how long this little AC unit and the lights will run. It says 4 hours, but I bet we get about, maybe 3.5, give or take. Okay, so now it's been a little while. This has been running for probably over an hour, give or take. And as we take a look at our watt meter here, it says 0.64, so that'd be about 640 watts, give or take. We'll go ahead and scroll through. An hour and 15 minutes of runtime, roughly drawing about 536, 540 watts, give or take, from this AC unit and also the two lights that I have running. All right, so it's been running for quite a while now, and only 23 minutes left at 13%, and the wattage has gone up just a little bit because it is getting hotter outside, and we've used about 1500 watt hours so far of this battery. So far it's doing pretty good actually. And back again, so now you can see we only have 6 minutes left and 3%. And not to mention, it is really hot in the garage. It's about almost 100 degrees, so that will rob power as well. So you could probably knock off a couple 2 or 3% for that. And now if you look, we're only down to about a minute left, so we're at 3 hours and 7 minutes and 1.69 as far as watt hours so far, running 2 minutes left and 1%. And now we're down to 1 minute and 1%, so this should be shutting off pretty quick. As we take a look at our numbers here, 1.71 kilowatts at 3 hours and 9 minutes, so probably be about 3 hours and 10 minutes, and 1.72 kilowatt hours, so we'll go ahead and let it run till it dies. And there it goes, it shuts off, and so does the meter. So we're going to go ahead and go back over the numbers, and we'll see what we get towards the end. So as we take a look, the unit provides 1997 watt hours, but we are able to pull 1720 watt hours out of it, and we lose about 10% due to the inverter conversion from DC to AC. Plus with the high temps, that's another couple percentage. So at 1720 watt hours out of this unit, seems to be right on par. Let me know what you guys think in the comments down below. Be sure to smash the like button and subscribe, and until then, I hope to see you next time.